We're having some technical difficulties, but we're going to go ahead and go through some of the IGSPA updates, and then hopefully we'll have our speaker here shortly. But I appreciate everybody attending this morning. Welcome to the February Town Hall. We've got a great speaker today who needs no introduction, but I'll introduce him anyway once he gets here. Our webinar this morning is sponsored by LoopTech Geothermal. Founded in 1984, they've been doing installations throughout the United States, even in Mexico and Saudi Arabia. LoopTech was our diamond sponsor at the conference this past year, December 2023. So we appreciate their sponsorship. I'm going to go through just a few updates before we get started with our speaker. And we will have the opportunity then to ask any questions in the chat as we move forward. So some of the latest IGSPA news to get started with. Our 2024 town halls and Dig Deepers, we are still looking for speakers this year. If you're interested in speaking at one of these town halls or Dig Deeper webinars, go to the website, igspa.org, and you'll find a fairly large button on the website called Training and Events Calendar. When you click on that button, you'll see an abstract submit link, and feel free to enter in the information on the webinar that you'd like to speak about. I want you to make sure you save the date. Our next annual conference is in March 2025. We're pushing it back just a few months to go from a December to a spring conference. So it's a little bit more than a year for an annual conference, but I think it'll be worth the wait. A lot of good things going on. You'll see details on registration, hotel information, all that coming in March of 2024, so you have about a year to plan for that. We're pretty excited to be in Champaign, Illinois in March 2025. Stay tuned for all the latest information. Our research conference is coming up in May in Montreal. We have about 50 papers that have been accepted, so there are a lot of topics on research and development for the ground source heat pump industry from all over the world. We have quite a few Canadian papers as well as European and American papers. So I think it'll be a great conference to learn about all the latest trends in the industry. If you go to igspa.org, you'll find the registration link on there, so you can register for the research conference right now. And then there's information on there as well about hotels and so forth. The Geo Outlook magazine, hopefully you're receiving this. This restarted last fall. The January edition was sent out at the end of January, and it's published now twice per year, so the next edition will be in July. We're working with BNP Media, who also publishes Engineered Systems and the ACHR News and a number of other magazines. So our audience is actually quite large now, over 50,000 in our audience. Now, one thing to check on is if you have not received the January Outlook email, or if you've had broken links, please let us know. We did have some issues with some companies' security settings this past January, where unfortunately we had quite a few people automatically unsubscribed from the IGSPA email list. So if you did not receive the January Geo Outlook email, please let us know. Send it in an email to info@igspa.org, and we'll verify that you are still on that list. Google and Yahoo also made some changes to their privacy and security policies. So I think as that happened, there may have been some companies that changed their security policies as well and automatically unsubscribed some people. So if you didn't receive January Geo Outlook, please let us know. We'll make sure that you're on that list. The 2024 IGSPA membership program really is seeing some good changes. We have new levels. We have a directory only listing for businesses. There's a benefactor level for those who want to show a little bit more commitment and have some additional benefits for the membership. We also have added retired and student rates. We have new lower rates for schools and community organizations, and everything is just better refined and defined, I should say, for utilities and other stakeholders. There's also a discount. If you're renewing your certification with IGSPA, you'll want to be a member. It's a pretty substantial discount for members on that certification renewal. If you haven't seen the new 2024 membership program, that's at igspa.org/membership. And there are quite a few details on there, or feel free to contact us. We'll be happy to go through that. If you haven't been on the member portal for a while, you'll see some new resources. We have a new marketing resources page, which has a lot of social media posts and videos and other information that members are welcome to help promote their businesses. We also have the latest reports on the grid impact study from the Department of Energy, as well as an Ontario report. So that's on the member directory. If you go to igspa.org and then select under the member menu, you'll find a member login right there. If you're looking for CEUs for your certification renewal, if you would, please add your name and your email address in the chat, and we'll keep track of those for you. So please add email and also your name. There's a new option for obtaining CEUs. If you're watching this webinar live, you don't have to worry about this, but if you are watching this as a recording, these get recorded and posted on the website, then you'll want to enter this code where it says Town Hall Webinar Code. So if you're watching this as a recorded session, you'll need that code in order to get these CEUs. Just a little housekeeping. Once we have our speaker here, we'll ask Steve to go through his presentation, and then any questions that you have, please add to the chat, and we will automatically go through those at the end of the presentation. Everyone is automatically muted at this point, but we will unmute everyone later on. I know we have had some difficulties with people using the chat, so I'll keep an eye on that, and I will read all the chat questions. If I do see where we're having some issues with the chat, then I'll open up those microphones. All right, just a quick disclaimer and potential conflict of interest, and then we will check and make sure our speaker is ready to go. The upcoming presentation represents the opinion of the presenter and does not represent any official position, opinion, or endorsement of any products or services by IGSHPA or its members. IGSHPA Town Halls and Dig Deeper webinars are for member updates and education on the latest information in the geothermal heat pump industry and are not meant to endorse one technology or brand over another. It is the presenter's responsibility to disclose any conflict of interest or position that may arise in the content of the webinar. All right, I think we are ready for our speaker now. Steve, have you been able to join us?
I'm here.
All right, what timing? That's great. Well, this is a man who doesn't need introduction, but I need to introduce him anyway, and also thank LoopTech again for sponsoring this session. Steve Kavanaugh is Professor Emeritus from the University of Alabama and owner of Energy Information Services. He's the author of HVAC Simplified, that's a 2006 ASHRAE publication, the primary author of Geothermal Heating and Cooling, an ASHRAE 2014 publication, and ground source heat pumps published in 1997 by ASHRAE. The 2006 ASHRAE HVAC book and the 1997 GSHP book are among the top 5 all-time best-selling books published by ASHRAE. He is a fellow of ASHRAE and ASME. He has lived in 3 different GSHP homes beginning in 1960 as a child, so it's in his blood. Dr. Kavanaugh has presented over 175 GSHP and HVAC short courses to over 5,000 attendees. He's publisher of Outside the Loop, an alternative publication for skeptics of conventional HVAC and GSHP wisdom. That's at geokiss.com. That's a site I go to quite often. It's got a lot of good information there. Several free HVAC and GSHP software tools are available from this site. He was twice board chair of Habitat for Humanity in Tuscaloosa and was co-construction supervisor for 5 of the homes. So it's my pleasure to introduce Steve Kavanaugh as our speaker today. I'm going to stop sharing my screen, and feel free, Steve, to share yours when you're ready.
Okay. From beginning. Well, thank you, Jeff. It's quite an introduction. I would have made it a little shorter if possible. And I appreciate y'all having me today. I hope this presentation is helpful. As you can see, there's a lot of information out there. Some of it is very good. Some of it may be a little sketchy. And as I show you in this little, one of my favorite little cartoons is misinformation may be, in this case, fatal if you just don't have the right kind of information. So with that, let's get going. So who makes this stuff up? A friend of mine who does expert witnessing, he calls it the MSU method, when you have some information. And one of the things that caught my eye was a report, and I traced that report to this document that you see below that says the maximum potential reduction in the drilling, it doesn't say anything about connecting the loops, but would be 40 to 50%. And it just struck me as a little crazy. It did say that, you know, the estimated percentage of the loops is 32%, which is reasonable. But I looked at this document and I couldn't find who wrote it. But anyway, I do want to note that I'm using the term ground heat exchanger in this presentation rather than loop, bore, or well. So let's start with a couple of individuals who've been doing ground source heat pumps for a long time. So the first one is a friend of mine. He started out as met him when he was a co-op, an employee of a co-op, and his job when they got going was to do the training for contractors wanting to do ground source heat pumps. Well, after a few years of doing that, he left, started his own business. When he did that, he saw that there was, you know, needed contractors to support HVAC companies. People told him he's sitting on a gold mine, so he bought a drill rig and was doing residential jobs, which is really his love, but he had to do military bases and schools, you know, keep the doors open. And so these larger jobs, he'd have to hire drillers, and he could complete the headers and interior piping if it was HDPE. So during his long career, opportunities were up and down in 2 or 3 year cycles, but the bills constant, had a hard time finding engineers. They always wanted to use conventional chiller boiler systems and hook them to a ground loop. They wanted to use steel pipe. Their manufacturers didn't know much about ground source heat pump, and the system costs were pretty high. Last year, he's about to quit, but an architect called him up and wanted some of his assistance because he'd been doing ground source and the prices were going up. So there was a push from the engineering firms to go back to doing chill water. And so he was trying to help out, but the engineers pretty much discounted him because he was just a dumb old contractor. But he did have some success using some engineers and contractors from about 1,000 miles away. But of course, the access was limited. So what happened is one architect and several other ones kind of had jobs lined up that you know, provided opportunities for ground loop contractors for steady opportunities. So he managed to locate some drillers that were doing 3 and 4 loops a day, ground heat exchangers today, but they were only from 700 miles away. And they wanted to be guaranteed 18 days of work per month, and each person required $300 a day per diem when they were out of town. And so this worked out well because the local contractors could do the headers and the purging, and they got the cost down and made good economic sense. However, engineers just didn't know much about them, so they would add large factors of safeties. And one of the things that really concerned me was the mechanical contractors would add a percentage onto the final bid of the ground heat exchanger contractor bids. So the search for more engineers goes on, and this contractor feels that engineers need to visit the job site to understand how to design the headers. And they need to understand, you know, how much steel pipe costs, and, you know, how much especially schools have in maintaining water treatment. And of course, there's concerns about investing and expanding their operations, given that, you know, the industry may downturn especially if subsidies are discontinued. So I think a lot of people are not familiar with what goes on in the field. I feel like we could get water well drillers to ground source heat pumps, but you got to realize that water well drillers, they do one hole a day. They put the casing and the dip pipe and a pump down in a well, and they only have to dig one trench into the building. Contractor, ground heat exchanger contractor does 5 holes a day, maybe 10. And each one of those holes has 2 pipes going in the building, and you have a lot of trenches going in the building. So the drill rig operates, 4 or 5 times, maybe 10 times as much per day as a regular rig. So it's going to need more maintenance. And a well driller a lot of times just will be developing the well to make it flow better and just watching the pump or compressor go. The well driller can also do a well test, and you can measure, pumps the well, measures GPM and the drawdown, how far the water gets sucked down, to do the test. And usually, if you look at the graph there, he's going to get paid more than a ground heat exchanger contract, and probably doesn't work as hard. So I've got over here something that my friend Kevin Rafferty, co-author, would like to say. These are the reasons why the open loop systems on big ones cost less than closed loop systems. Okay. Now here's another contractor. He had 5 drill rigs. They worked from South Texas to Ohio. He was also a rep for a manufacturer, but the second one that he was working with, he left them. Didn't feel like they were building good equipment. Had a hard time competing with the oil and gas industry for drillers. You had to hire them with no experience and then train them for 2 years before they could get a license. And of course, once they got a license, they find higher pay opportunities. So the difference, going to a different site a long way away, you got to have at least 4 vehicles with all this equipment. He also owns a shop and other miscellaneous buildings. And like the original first contractor, opportunities up and down. So this loop contractor is well beyond, I'll say, beyond normal retirement age. He's even older than I am. But so he's cut back to 1 rig from 5 to make a business affordable. So here's what he provided. He showed me some costs. You can see they all went up. Some of them almost doubling for the rig and the skid steer and the mud puppy. One thing that shocked me was, drilling's kind of dangerous compared to doing an HVAC technician. So the insurance cost for workman's comp was much higher. And shockingly, the insurance cost is 10% of the gross income. And of course, when you do a larger job, it costs more. And almost all of the jobs that they did were required distant travel. Per diem costs were about the same as the other contractor. And of course, again, the equipment maintenance costs were higher for the drill rigs. So getting to the point of this, improved simplified commercial and institutional mechanical and ground heat exchanger designs. Simplify them, make them better. Improve interactions with the ground heat exchanger contractor to improve the loop designs. We're looking at equipment with simple, non-proprietary controls for the baseline equipment. Still be real efficient, extremely efficient, without advanced controls. Be nice to make it easier on the HVAC contractors by doing something like plug and play wiring between the equipment and thermostat. And another thing is production of high efficiency. One of the things that sometimes gets lost in the advantage of ground source heat pumps is they last a long, long time. And so the equipment needs to be simple and last a long time without a lot of service, especially controls problems. Okay. So we did a survey for the Southern Company and TVA and EPRI, and there were surveys done previously. So looking at those older surveys, what we saw was the heat exchanger costs from 2011 to between and 95 was increased by 50% or 3% per year, but the HVAC cost was 74%, and it increased by 11% per year. So really, we need to look at real hard at the inside, the HVAC stuff. Okay, so here's a graph that was generated. You can see the previous surveys were done here in the 90s, early 90s, and then the TVA sponsored an architect of all people to do another survey in 2000 because they were real interested in it. And then this is the one that was sponsored by the TVA, EPRI, and the Southern Company. You can see here the empty symbols are the loop cost, and then the solid signal symbols are the total cost. So you can see the total cost going up a lot faster than the loop cost. Also, there's this report. A lot of people don't realize that drilling is not all the cost. So this report, we got some information from some larger systems where they broke out the loop cost, just drilling costs, and the total loop cost. So you can see sometimes from this graph, here's the drilling cost, and then for a few jobs, the headering cost was more than the drilling cost. This line right here represents the header cost, percent of the header cost. So you can see just a little under 50% of the cost is in the work of the header. Okay. Now I promised you some numbers. Here's a project done in Alabama at a resource center, which is what we used to call libraries. This was done by some very good engineers. It has low energy and happy occupants. You can see, I'll show you something in the next slide about the surveys we did, but you can see steady demand. This is the bill demand, so I'm not sure what the real demand is, but you can see an EUI of 27.6, which is excellent for the annual use. And so this is in the ASHRAE Journal in April 2018. But one of the things we like to do is when we're doing surveys, which we haven't done in a while, but is to try to get where things going well, where cutting costs, cutting energy, really continuing to provide good information. So we asked about the temperature, occupant temperatures, heating and cooling, air quality, the lighting. You can cut the lighting down and get high efficiency, but make people unhappy. And then acoustics. Sometimes equipment can be placed in areas close to the thing, and the maintenance. But the real kicker that we got a lot of feedback from was, can you set your own thermostat? Okay, so that's how we got these numbers. This is the best one I've ever seen in what we've done. Okay, so here's what happened at the site. The cost was broken down. The engineers were able to get costs from the general contractor. You can see the main thing here. This is a lake loop. So its cost was $1,286 per ton. Okay, so $151,000 for the equipment, which if we break this 70, divide that by 70, it works out to be $2,157 per ton, which would mean a typical 3-ton unit would be $65,000. And this was in 2015. But the real, eye-opener is the control costs. Okay, almost the same as the loop cost in the lake. And so you could see $81,000 for 70 tons. That'd be like spending $3,470 on a 3-ton thermostat. So that's kind of shaky. Now, there was also we had a contract with Southern Company. They were interested in getting in the business of doing ground source heat pumps, and they wanted to know how much the premium was on the ground source system But they didn't want to compare it to just typical. They wanted a high-end system, a cooling coil, not a cooling coil, but a cooling system. And we did that chill water, a constant volume system and chill water VAV, and compared that with the ground source heat pump, where we assumed a $15 per foot of bore. And this was in 2016. So you can see the ground source system was actually less expensive than chill water VAV, okay? Because what people don't realize is that when you're running a chill water and a hot water loop inside a building, those are pretty expensive, you know, just as expensive sometimes as the ground loop. So you can see that this is people that do this know that if you do the ground source heat pump simply, you're going to be less expensive than chill water VAV. And there's some details in this report if you want to look at it, okay? So here's why it's so expensive to do chill water VAV. This is, and the other thing is, look at all the stuff that's in these systems when you want to do a high-end, high comfort, so to speak, system. Look at all these pumps. And then, of course, what they do is they have a big central fan, which often uses as much power as the chillers. Have a return fan, and then in each terminal, this is the VAV system, you also have a fan, because what happens when you have variable volume air is the air just tends to flop out and doesn't distribute well. So a lot of times they'll have to put a fan powered VAV box in there to distribute the air. So it's a lot of different things. And when you add all that stuff up, if it's a water cooled, the COP is 8.3. And if it's an air cool system, it's down to 5.7 because of all this stuff, okay? So we don't want to do that, okay? Now, when we go to, say, take this system and hook it to a ground heat exchanger rather than a cooling tower and a boiler, I mean, the system cost goes through the ceiling. So you can see that with this next thing. So look at this. When you do a ground source heat pump hooked to a chill water system, the costs are pretty much outrageous. So hope nobody's doing that. Now, let's go into the engineers. That's my profession, okay? So here's a system that a contractor just sent me. Says 291 ton school, and it's 382 feet per ton and 66-degree ground. Good conductivity and use 1.25 inches, good grout, and 15-foot bore separation. Okay, so the program that this design engineer used said if you want it to last 25 years, you have to make them this big. And then, of course, at the end of 25 years, you'll have to abandon the loop. Okay. Also, the things that loop contractors really don't like is 32 bores on a circuit. And if you look at this, each takeoff had 2 bores on it, okay? Very difficult to flush, okay? Now, I always like to quote Terry Proffer, a guy that's probably fixed more bad geo jobs than anybody I know. And his comment is, if you're going to connect more than 12 loops on a circuit, you better have a good reason. So thank Terry for that quote. Okay, here's a little bit more about that thing. During the long-term ground source heat pump performance project, there was only one variable speed pump system that had a full load differential temperature of more than 4 degrees. And it was designed by a contractor, the one that I showed in the first set of slides. He designed this system and it worked pretty good. Now, this is the one on that, similar to the previous slide. Here's the pumping thing. So installed pump power was 21 horsepower per 100 tons. So if you look real close, you can see the delta T here on the ground loops, only 2.3 degrees F rather than 8 to 10. And in the building, it's 2.3. And you see they've got 2 15 horsepower pumps doing the building and 2 15 horsepower pumps doing the ground loop. So the pumps at this point are drawing about 28 kW. if they could cut the pump size down where they get about 10-degree delta T, that power should only be 3 to 4 kW. So this has become essentially an inefficient system. Okay. Now the loop contractor was able to find an architect. There's a couple of good architects out there who they went searching for some different engineers that were more local, and they found a group, and these engineers were, unlike a lot of us, were open to, people helping them do their design. So they came up with this design, and the reason they did consult the ground heat exchanger contractor how to lay these things out. Okay, so this is one loop of several. I think the system had about 10 of these, and you can see each one of these has 3 just like this. So, and you can see the pump power was only 8.3 horsepower per 100 tons. So the contractor was shocked that an engineer was listening to him. So, good friend of mine had a coffee cup sent to her that had from her relatives. It said something about engineer that we tend to be this way, I hate to say. But if we look at the directory, there's only 21 engineers, architects listed, and only 13 of these will do design. So engineers and architects don't like to be grouped with together. But let me tell you, there are some good ones out there. But it takes some time to find them, but there are some very good engineers out there. So hopefully we'll get more of those. Okay. Now, the other thing about the cost is the cost of the control systems. You can see this is the Department of Energy does surveys, and you can see that in the 2018, the building automation systems use more energy per year than thermostats, with programmable thermostats even using a little bit less than smart thermostats. When we did the survey, we saw that the building automation systems had an average Energy Star of 61, whereas the those with thermostats had a score of 80 out of 100 because of the controls. So the question I've always wondered, and a lot of people agree with me, not everybody, but does complexity lead to dissatisfaction? Okay. So here is controls for a variable speed. This is one page of 7, okay? And this is the controls diagram, complete of a single speed water source heat pump of a small manufacturer who's rated very highly. So let's look at this, okay? So does complexity lead to dissatisfaction? So here is the top ranked air source heat pump. You can see, look at this, 143 very unsatisfied people versus 318 that were very unsatisfied. So we go down to this smaller mid-sized ground source heat pumps, and this is what you want with ground source. This is what you deserve. This is what you expect. Only one person was very unsatisfied out of 14 being very satisfied. So we go to these larger ground source heat pump manufacturers, and they are a little bit better than the air source, but not much, okay? When you're having a ground source heat pump, it should be like this, not like this. So, so if you look at what's facing contractors, service people, especially people in schools, we found that on average, each school had about one tech for every 5 buildings. So think about it. You have 5 different manufacturers on these 5 different schools, 5 different proprietary control systems, each installed about 4 or 5 years apart. And probably the oldest ones are obsolete. And you're not paying the school technician all that great. I mean, they get good benefits. So the tech, if he's good, he gets good at it. And if he's good at it, he's hired away. Okay. Ground source heat pumps with simple controls and single speed compressors that last 25 to 30 is a better option than anything that I have come across. Okay. So some of the things that would be helpful if we're going to make a big expansion in this where we have a lot more people using this, like homeowners and schools. small offices, we're going to need to make things simple. So here is a diagram of a typical older ground source heat pump system, like the one at my old house that's 30 years old. And you can see these components. Really all you've got on a circuit board is this right here. You can see the cost from some other circuit boards. And this particular manufacturer at one time would actually put their circuit boards on Amazon. You can buy them. So where you can get these lower cost mechanical controls, which are typically more durable. Okay, so let's look at this. Here's a air-to-air heat pumps. You can see this particular manufacturer, which was the one that had the good ratings, had a cost similar to an air-to-air heat pump for a single speed, and for the dual had about the same cost, a little bit less. Okay, but then these larger manufacturers that have EERs less than this one had much higher cost. Okay, and these costs come from an online manufacturer. This is not from a manufacturer direct. So the question is, why does this cost way more than this, even though they're about the same in terms of simplicity? This has a fewer fan, has a lot less metal in it because this coil is so much smaller than this outdoor coil. And then one of the questions, this online manufacturer, in March 2022, it was $6,500, and then 18 months later, it was $9,500. So you wonder what's happening here. Here's a manufacturer that makes, what this manufacturer does is they put the same equipment in terms of the coils and the compressors and everything on their single speed machines as they do on their two-stage. Okay, so if you look at this, the single stage at this, where they're comparing apples to apples, has a higher efficiency in both heating and cooling and heating than the dual two-stage. Okay, even though it's going to cost more. These other off peak ratings are kind of, in my opinion, bogus. And water source heat pump manufacturers have to come up with something like this because the air source heat pump ratings are way more bogus than these part load ratings. Another thing that we found is my brother had a friend named Mike McGee, and he was going to put a chrome wheels on his 57 Ford Fairlane, and told his dad, and his dad's a welder from Oklahoma, said, son, that's like putting a $500 saddle on a jackass. Okay, so I think that's what we're doing with our fans. We've got a very expensive motor here, and we're linking that to this squirrel cage fan, which is terribly inefficient. Okay, so efficiency ends up being 30. And they also make PSC motors that are very efficient. You can see by checking the full load amps. Do that. Don't look at just look at the full load amps when you're looking at these things. So the efficiency is still not great. So what we would like is this sort of thing where we have a backwards curve impeller with a motor. It could be ECM or it could be PSC, but you can see this PSC efficiency is much higher than here. This is kind of unfair. I can buy these things from a surplus, new ones for pretty cheap. So these things aren't all that expensive. Okay. Now, simple, high efficiency, long service life units, so we can have a greater penetration markets. So we want to put those high efficiency fans in here, and we want to standardize the controls and maybe make little connectors between the thermostat. We want to have larger connections, low head loss coils, so we don't have to have such big pumps. Single speed throw compressors, they wear in, not out. We can have a optional coil here. And then of course, it'd be nice to have 2-inch filter racks and ratings that were at reasonable conditions, like in the cooling 75-63. And they would also be able to tell us how much sensible cooling, how much latent cooling has been done by machines. So a lot of these high ratings come at the expense of dehumidification capabilities. Okay, finish it off, my summary and conclusions. Quality design and installed ground source heat pumps are a superior HVAC technology due to efficiency, long life, and potential simplicity. So we need to create an atmosphere where it's critical to get ground heat exchanger contractors in the business and not ask them to cut their costs by 40%. So this kind of counterproductive. I think we have evidence, if you look real hard, that advanced controls aren't what they cracked up to be. And poor ground source heat pump design is common. And there are ways to evaluate engineering design. Some of the things that we've laid out, you just need to go in and have engineers and architects submit the results of their systems, okay? And finally, we can be very efficient with ground source heat pumps without all the bells and whistles. And a goal for wider adaptation of ground source heat pumps is to eliminate the current premium and hopefully get our costs down even lower, okay? And finally, let's see, the last slide is what's going to happen if we get subsidies cut out again. So hopefully we have a little time for questions.
All right. Thanks so much, Dr. Kavanaugh. It's always good to hear from you. We already have some good questions. So let me start at the beginning of the chat here. Also, I see some hands raised. I know some people are having difficulty with the chat for some reason. So I'll read through the chat and then we'll look at whose hands are raised after that. So our first question is from Jackie. She says, with regards to difficulty of attracting water well drillers to ground heat exchanger installers, it appears that today there is potential for much higher gross income per day on a ground heat exchanger job versus a well water project. Is my assumption correct? And if so, will that make it easier to attract water well drillers to ground source heat pump drilling?
Okay. Can you hear me?
Yes, yes.
Okay. So the assumption, the profit margin was higher. Is that what the for a ground loop contractor?
She mentioned that the difficulty of attracting water well drillers is because of the gross income per day on a one of our jobs, a ground loop job versus a water well project. So if that assumption is correct,
that's an issue. And part of that issue is the way two things that stick out in mind is bad engineering design, okay? That makes these things difficult to install, difficult to flush.
57 feet.
And also the fact that sometimes the loop contractors have to travel so far. They're not local. And so I think if you look at somebody like Dandelion, where they have restricted their area, not going across the country to do loops, I think they're probably got a good idea there.
Okay, thank you, Steve. I'm going to go to the raised hands now because we do have some people who are not able to access the chat. Jeff Volmart, you have your hand up first.
Yes, sir. Dr. Kavanaugh, I actually worked with Kirk Metzger a long time ago, and I still work with Wayne and Rory, so I'll tell them you said hi.
All right.
My question is, how are you controlling humidity? Are you using hot gas reheat coils, or are you using primary air systems to control humidity in the building? I do a lot of schools, the reason I ask.
Okay. Well, this is the one thing is that the push toward extremely high efficiency mandated is you never know what you're getting from a heat pump. Okay, so none of the manufacturers have to tell you what the sensible heat ratio is. Okay, you're also testing these things at 80.6 degrees, which is way out of the comfort zone. So basically, design engineers don't know what the things are dehumidifying, and usually they aren't dehumidifying very well, especially if it's a variable speed machine that's running at a ton or ton and a half, and it's hooked to say a 4-ton coil. That's not going to dehumidify. Okay, so the point is that, first of all, we have to build machines that dehumidify, and that's not being done, okay? We have to get those machines in those schools down to 325 CFM per ton and still get efficiency, okay? The other question is I think what engineers in schools are doing now is they're using that ionic system for it's called the different method of looking at outside air, where they're cutting the outside airflow rates down in about half, using the alternate method in the ASHRAE standard. So it's typically what I see a lot of is doing. It's not a good idea in my mind, but they're using these large DOAS units with wheels.
I'm not allowed to do that.
Yeah, well, you shouldn't be. So it's a challenge, but these machines aren't dehumidifying. That's part of the problem. And I think what your comment about hot gas reheat is probably what some people are doing, but of course that really compromises your efficiency. Dehumidifiers compromise your efficiency. So I think if engineers had a better idea of what the machines were doing and they were designed to dehumidify, we'd be a lot better off.
Thank you very much.
Tough question.
Yeah,
Thanks.
that is tough. All right, there's I'm looking at the chat here. We have some really good exchanges about drilling costs versus horizontal versus pond loops. Do you have any comments on that? Preferences, or I noticed your presentation's mostly vertical. Can you touch on other options?
Yeah, it's hard to get everything in. Pond loop's the greatest thing, but to do a good job in cooling, the pond needs to be a little deeper than 4, 5, 10 feet. So I think the pond loop is a good option, and we've got ways of designing those things. Now, in as far as horizontal, you have to realize most of my experience has been in the warmer climates, and I would not be real big on horizontal systems unless you can get them down 10 feet in southern climates. They've got to be deeper in these warmer climates. And so I think while my experience has not been as large, if you do have enough area in colder climates, they can do quite well. And then, of course, if you have a pond that's 40 or 50 feet deep, it's a great way to cool. And then, of course, efficiency of a pond loop in the winter is not going to be quite as good as a ground loop. A horizontal loop or a vertical loop, it's going to be a little bit less because the pond's going to be colder.
Thank you. All right, we're going to go back to the raised hands here, since some people are having trouble with chat. Sherry Rice, if you'd like to ask a question, please.
Hi, sorry, I couldn't get unmuted.
She's pretty good at talking usually. So
I am not able to access the chat, and neither is Ray. And I know he wanted to make sure to get CEUs and also had some questions that he wanted to put in there.
Okay. Do you have those questions, Sherry?
I don't.
Okay. All right. Feel free to speak up, Ray, if you like. Okay. While we're waiting, let me go back to the chat here. Let's see here. Ravi has a question about cost effectiveness of networked ground source heat pumps. Could you comment on that, Dr. Kavanaugh?
Are you talking about like the community systems?
Yes,
Okay.
That's what I'm assuming. Yeah.
Well, it depends. I think when a lot of people that are big proponents of these systems don't look at two things. As you notice there of course, there's old data from 2001 where the cost of hooking all these loops together is equal to the drilling cost. Okay, so my I won't say guess, my not completely substantiated feeling is that the larger that system is, the more trouble, the more costs interconnecting all these loops. So the savings in ground loops won't be all that great. The other thing is a lot of these efficiencies that get bannered around don't include fan power, don't include pump power, and those things can be huge, especially if you've got a neighborhood. So I have reservations about the community systems. I think you need to look at them real hard. And I think if you have a question about them and you send me the schedules out of your design, I can show you how to predict how much the pumps are going to use and how much the fans are going to use. And you'd be shocked about how much these things can use. Okay.
Thank you for your comments. It looks like Ray is here and has his hand up. But Ray, go ahead.
Can you hear me, Jeff?
Yes.
Okay. Dr. Kavanaugh, great job. First, I'd like to say you've touched on a lot of really wonderful things. And I'd just like to make a couple of comments on horizontal versus vertical. You've got to have an awful lot of land to be able to do that. That's the drawback to horizontals, and then getting deep enough. But the cost of the equipment in the time that I've been doing it for 35 years, the cost of the equipment is 4 times more expensive now today than it was when I started, and the loops have just now doubled in cost. And so in our experience, we have units that's been out there for over 30 years, some of them 35 years, that's still working, that we don't have to service at all. And we've got units that's got all of the bells and whistles, and we have nothing but problems with a lot of them. And so if we could manufacture our equipment to keep it simple, then we would have, that's the only way we're going to penetrate the industry. We're never going to be able to compete until we decide that we're going to make equipment that will last long. And right now, if they last 5 years without breaking down, the new ones, we're lucky. Like I said, I've got some out there that's 35 years old that's still operating today. So I think you made some great points there, Dr. Kavanaugh. And I don't really have a question. I just wanted to make those comments.
I was hoping you didn't have a question because I knew it'd be a hard one.
Not for me. I'm too simple. I like to keep things simple. That way they work. Thank you, sir.
Thanks for the
All right.
comments.
Looks like we have about 2 minutes left, so we have time for one more question from Victor. He says, it sounds like you're saying simple needs to be distributed heat pumps on a shared source or sink loop. Are there designs of central plant water-to-water heat pumps that you would recommend as simple?
Well, I mean, there are things that you can do with water-to-water heat pumps. Like, they're going to be inherently more inefficient because you got that extra heat exchanger in there. But there are things you can do. In-floor heat is, getting rid of all the fan power. Okay, you keep those pumps small. That's a great way to do it. And of course, there's this chill beams in drier climates. I think people are backing away from that. I wouldn't want to do one, but apparently there's a lot of climates where you can do the chill beams, where again they're efficient because the fan power is gone. Okay, so there are ways of doing the water to water, but doing chill water VAV is like that's just like driving some big monstrous truck thinking you're saving electricity because it's a hybrid.
All right, very, very good. Well, thank you so much, Dr. Kavanaugh. This session will be recorded, so check back on IGSPA.org in a few days, and you should see this recording saved there. I really appreciate your presentation, and I appreciate everybody's time today. Have a great rest of the week. Thanks so much.
Jeff, I want to just say thanks for letting me do this, and if anybody hadn't heard me say this before, this guy's doing a great job with IGSPA, and thanks for doing it.
Well, thank you so much. Take care, everyone. See ya.